All right, so today we're diving into something pretty wild. We're talking about flat Earth theories. You sent me a ton of stuff about this, articles, forum posts, even whole podcast episode.
Yeah, it's really interesting. We're not just talking about a few people on the fringes here. There's a whole community out there. A lot of people who truly believe that the Earth is flat.
It's kind of mind-blowing, right? Like in the age of satellites and GPS, people still look up at the sky and see a flat Earth. So I guess the mission for this deep dive is to try to understand not just what they believe, but why.
Exactly. And I think listening to that podcast you sent, that's from a group called the Flat Earth Society, right?
Yeah.
That's a good place to start, to kind of hear directly from them how they explain their worldview.
Yeah, so let's jump into that podcast. And one of the things that struck me was they seem to have a pretty clear picture of what they think the Earth actually looks like.
Yeah, a lot of flat earthers subscribe to this model, where the Earth is like a disk, the North Pole is at the center, and then Antarctica is this giant ice wall that surrounds the whole thing.
An ice wall, so no sailing around the globe, I guess.
Yeah.
What about the sun and moon? Where do they fit into this?
So they picture those as much smaller than we think. And they basically circle above the Earth, like spotlights.
Like spotlights. Okay, so it's like giant pancake with spotlights. Makes you wonder what's on the bottom of the pancake.
Yeah, they have theories about that too. Something about like a dome or a firmament covering the Earth.
Okay, so they've got a model, but what kind of evidence do they use to back it up? In the podcast, they kept talking about observations they've made and experiments.
Yeah, one of the big ones is that, when you look out at the horizon, you don't see a curve. So they say, well, if the Earth was really a sphere, you should be able to see that curvature.
Right. Like they always bring up that example of being able to see the Chicago skyline from across Lake Michigan.
Exactly. But, that's explained by a phenomenon called a superior mirage.
Right, where light bends because of the temperature difference.
Right. But to someone who's already convinced the Earth is flat, that picture of the skyline is like proof.
It seems like a lot of their arguments come down to what they can see with their own eyes.
Yeah, it's interesting. It's not that they're completely against science, but they have a very different idea of what counts as scientific evidence.
Okay, well, speaking of science, haven't we known that the Earth is round for centuries? Didn't the ancient Greeks figure that out?
Oh, yeah, definitely. Thinkers like Aristotle and Eratosthenes, they use observations of stars and shadows to not only prove that the Earth is round, but to actually measure its circumference.
And then, of course, we have like hundreds of years of scientific advancement, people sailing around the world, pictures from space.
Yeah.
But the podcast hosts, they kind of dismissed all of that, especially anything from NASA.
There's this deep distrust of authority, especially institutions like NASA, that they see as part of the scientific establishment.
So it's not just about the shape of the Earth. It's about distrusting the systems that give us information.
Yeah, exactly.
Okay, so if they don't believe in gravity, how do they explain why things fall down?
So instead of gravity, they have this concept called universal acceleration.
Universal acceleration.
They believe that the Earth is constantly accelerating upwards.
So we're not being pulled down. We're being pushed up.
Right, which they say explains why objects fall at the same rate, no matter how heavy they are.
That's pretty wild.
Yeah.
But if the Earth is constantly accelerating upwards, wouldn't we eventually hit something?
Well, they say that the whole universe is accelerating upwards along with the Earth.
So we're all just like on this giant elevator going up forever.
You're starting to see how this requires a pretty big leap of faith and reimagining of physics.
Yeah, it's a pretty complex web of beliefs.
Definitely.
But it's fascinating. I mean, there's so much to unpack here, and we've just scratched the surface.
Yeah, definitely. There's a lot more to their worldview, and they have explanations for everything from eclipses to seasons.
All right, well, this has been a really interesting start to our deep dive, and we've got a lot more to explore. We need to look at the science that contradicts these flat Earth ideas.
Right. Yeah.
And we need to talk about the psychology and social factors behind these beliefs. So stay tuned.
Yeah, things are going to get even more interesting.
So we've talked about the flat Earth model and what they believe. But what about all the evidence that contradicts that? Like, what about Foucault's pendulum? Doesn't that show that the Earth is rotating?
Yeah, that's a great example. The way the pendulum swings, it slowly changes direction over time.
Right.
And that's because the Earth is rotating underneath it.
I remember seeing one of those in a museum. It was really cool to watch, but I don't think I really understood what it meant.
Yeah, well, the basic idea is the pendulum wants to keep swinging in the same direction, but the Earth is spinning. So it looks like the pendulum's path is changing.
So if the Earth was flat and not moving,
Yeah.
the pendulum would just swing back and forth. Same way all the time.
Exactly. But flat earthers have come up with ways to explain that away. They say there are hidden forces or something that makes the pendulum rotate.
It must be frustrating for scientists to see all this evidence dismissed like that.
Yeah, it can be. But it shows that just presenting facts isn't always enough. You have to understand why people believe what they believe.
Okay, so Foucault's pendulum shows that the Earth is rotating, but what about the effects of that rotation? Like the Coriolis effect?
Oh, yeah. The Coriolis effect is fascinating. It's how the Earth's rotation affects things like weather patterns and ocean currents.
I vaguely remember learning about that in school. But how does it work again?
Well, imagine you're trying to draw a straight line on a spinning basketball.
Okay.
That line's going to look curved, even though you drew it straight, because the ball is moving underneath you.
Right, it's all about perspective.
Exactly. And that's what happens on Earth, because it's rotating things that are moving long distances, like air and water. They appear to curve.
So that's why hurricanes spin in different directions in the northern and southern hemispheres.
That's right. And even snipers have to take the Coriolis effect into account when they're aiming over long distances.
Wow. I never realized all of that was connected to the Earth's rotation.
It is. And it's something that wouldn't happen on a flat Earth.
So we've got Foucault's pendulum showing the rotation, and the Coriolis effect showing the effects of that rotation. Seems like pretty strong evidence to me.
Yeah, but flat earthers have counter-arguments for all of this. They might say that the Coriolis effect is exaggerated or that it's caused by something else.
It feels like every time you present evidence, they just come up with another explanation.
Yeah, that's pretty common with conspiracy theories. The explanations get more and more complex.
So how do you even have a conversation with someone when they're so set in their beliefs?
I think the key is to start with respect. Acknowledge that they're curious about the world and that they want to find the truth.
Instead of just telling them they're wrong.
Exactly. You could say something like, it's great that you're asking questions and trying to understand things.
Yeah, that makes sense.
Yeah.
Everyone wants to make sense of the world.
Right. And then you can try to gently point out inconsistencies in their thinking or offer alternative explanations.
But without being condescending.
Yeah, that's important. Because if you make someone feel stupid, they're not going to listen to you.
So what do you do when someone brings up something like that Chicago skyline photo?
Well, instead of just saying, that's wrong, you could explain how superior mirages work, and then maybe talk about other evidence that supports a round Earth, like how ships disappear hull first over the horizon.
Right, because that's what you would expect to see if the Earth was curved.
Exactly. And, you're not going to change someone's mind overnight. But maybe you can plant a seed of doubt, or at least have a respectful conversation.
Yeah, that's a good goal.
And even if you don't convince them about the Earth, you might learn something yourself about how to communicate about science.
That's a good point. Well, this has been really helpful. We've talked about the flat Earth model, their arguments, and even how to engage with those beliefs.
Yeah, we've covered a lot of ground.
But there's still more to explore. We need to talk about the psychology behind these beliefs.
Right. Why do people believe in conspiracy theories?
And what are the broader implications of this distrust in science?
Yeah, we'll delve into all of that when we come back.
Okay, so we're back. And, we've been really focused on this one podcast from the Flat Earth Society.
Right.
But this is just a tiny part of a much bigger thing, right?
Oh, yeah, absolutely. There's a ton of Flat Earth content online, YouTube channels, forums, social media groups. It's a whole world.
It makes you wonder, how do all these communities form? Why do people believe this stuff, even when there's so much evidence against it?
Yeah, that's where the psychology of belief comes in. It's not just about a lack of scientific knowledge. There are deeper reasons why people might be drawn to these ideas.
So what are some of the psychological factors that might lead someone to believe the Earth is flat?
Well, one thing is confirmation bias. That's the tendency to look for information. That confirms what you already believe, even if it's not true. And that's amplified online. Algorithms show you more of what you already like.
So you end up in these echo chambers.
Exactly. And flat Earth beliefs often go along with other conspiracy theories.
Right. It's like this whole interconnected web of distrust.
Yeah, you'll find people who believe in a flat Earth also believe in things like faked moon landings or government cover-ups. It all kind of fits together.
It's like they create this bubble where anything that challenges their beliefs is just part of the conspiracy.
That's a good way to put it. And for some people, being part of a community like that can be really powerful.
Especially if they feel like they don't fit in with mainstream society.
Right. It can be a way of rebelling against authority, rejecting the official narrative.
But even though it's good to think for yourself, you have to be careful not to go too far down the rabbit hole.
Yeah, critical thinking is important, but it has to be based on evidence and logic.
So how do we encourage people to be more critical, especially when it comes to science?
I think the most important thing is to build trust. Instead of lecturing people, we need to have real conversations, listen to their concerns, and try to see things from their perspective.
Meet them where they are.
Exactly. And it's also about finding common ground. We all share a curiosity about the world. We all want to understand how things work.
Right. So instead of trying to prove them wrong, we can try to encourage them to question their own beliefs.
And to evaluate evidence carefully. That's what critical thinking is all about.
Well, this deep dive has been really eye-opening. We've gone from talking about the specifics of flat Earth beliefs to looking at the bigger picture, the psychology and social factors that play a role.
It's been a journey that's made us think about the nature of belief, the role of science, and how to have respectful conversations, even about ideas that seem strange or unconventional.
I think the biggest takeaway for me is it's not enough to just throw facts at people. We have to understand why they believe what they believe.
Yeah, and we need to find ways to bridge the gap between science and these alternative worldviews.
So to everyone listening, we hope this has given you some food for thought. The next time you come across someone who believes the Earth is flat,
or any other conspiracy theory,
remember that there's more to it than just a lack of knowledge.
There are deeper reasons behind those beliefs. And if we want to have productive conversations, we need to approach them with empathy and understanding.
And who knows, maybe we can even learn something from each other along the way.